Hi, let me demonstrate this technology to you. I have an ultrasonic transducer here, and I have a sample that I want to inspect here. So if I don't have any coupling medium, I push down on the sample, and you can see here on the screen that there's no change in the ultrasonic waveform. So a commonly used medium is water. So I'll just put a little water on the surface. And as you can see, as I press down, you can see the waveform change, showing that the ultrasonic energy is transferring into the sample and it's reflecting back through the sample. Now this sample here has a defect. As you can see here, that the waveform changes. Now this area here is where there's no defect, but you can see the ultrasonic energy is coupled into the sample. And as we move the transducer over an area where there's a defect, we can see here that we get a difference in the ultrasonic waveform response. So I'll go ahead and dry off the sample in the transducer, and I'll demonstrate the solid couplant material. It's nitrile rubber on the surface of the sample, and then I'll place the transducer on the membrane. There again is a signal where there's no defect, and then if I move the transducer up, you can see that the peaks are closer together. You get the multiple echoes because there's a delamination at the midplane of the sample. Okay, so now what we've done here is that I have a transducer where we've now taken the solid couplant membrane, the nitrile rubber, and we placed it over the transducer. And it just requires slight fingertip pressure to help transmit the energy into the composite part. Okay, so that's no defect, and then defect there. Now I want to demonstrate this technology on a pipe with material loss inside, so that to simulate corrosion damage in the pipe. So if we take the transducer and solid couplant material and apply it in an area where there's no defect, you can see again the multiple echoes and the ring down effect. Notice the spacing. If I move the transducer over an area where there's a defect, you can see again the multiple echoes, but they're spaced closer together. One possible benefit of using the solid couplant membrane is if you have a rough surface that you have to inspect, you can go to thicker membranes. So you can lay that over the sample. You can either lay it over the sample or have it on the transducer, and then the thickness of the membrane will account for the surface roughness, so you can still do your inspection over an area that's rough. So now we have the transducer with the solid couplant membrane mounted to a voice coil motor, and what that does is applies slight pressure, okay, because it has a magnet in the coil. It can move. As I send electrical current to the motor, it can move this up and down. And as you can see on the screen here, as I slightly push down, you can see the waveform here, this signal here, which is the back surface of the composite sample that I'm inspecting. So now I'll apply an electrical signal to the linear voice coil motor, and that will produce the signal that was shown previously, but instead of applying fingertip pressure, now we are modulating the transducer assembly electromechanically, and that's shown here. So we're getting ultrasonic coupling to the transducer solid membrane. Because it's vibrating on the surface, we can move the transducer and still get the inspection. So right now we're vibrating the transducer on the surface, and we can scan it to make multiple measurements on the surface. And the vibration allows the transducer to move on the surface, or in effect float on the surface. Okay, so here is some data that we took previously on the sample that we performed this previous scan on. This is time, and this is voltage for all the waveforms that we've acquired. And so we can step through in time by moving this time window through the data. So we have the near surface indentation here from the impact damage, and as we slide this through, we can go through in depth and measure the extent of the damage that should be larger than the indentation, the subsurface damage. So as I slide this window through the data, we will be inspecting deeper into the structure, and we can see subsurface damage showing up here. And as we slide it further, we can see the extent of the subsurface damage shown here.